Alright, this is our video for the first lesson that we will do in Math 9. So, first chapter that we will work through is on symmetry and surface area. And this video will cover just an introduction to symmetry. So we'll go over some key terms and look at some examples. Lots of it will likely be quite familiar for you already, but we'll get some key terms down. Okay, so you can work through the handout of notes that I provided you in class and make sure that you get all the blanks filled in. Okay? An object or image has symmetry is the first blank, and symmetry occurs when the object is balanced and can fit into itself either by a reflection or a rotation. So those are two new words, reflection and rotation, that we need to define. We'll get to that. Reflections, rotations, and translations would be our next blank. Translations, or slides is sometimes another way that we talk about it. Slides are all examples of transformations. That a geometric figure can undergo. So transformations is just our fancy word for change. So these would be types of changes that all of any geometric figure, any shape that we talk about can undergo. So translations, we'll define that one first, and then we'll spend more time on reflections and rotations. Translations are slides along a straight line. So they are described by stating both the size of the slide, so how far it slides, as well as the direction of the slide. So, for example, if I have a triangle, okay, and I am going to slide it up to here, right? The triangle is still the triangle, but it has now been slid up. I would need to define that. I would need to say the size, how far. So maybe, I guess depending on which screen you're viewing this, maybe it's about 2 centimeters. That's the size, and then the direction would be up and to the right. Okay, and of course, if you were on a grid or something like that, you'd be able to maybe just count out the boxes, and you would say 3 to the right and 3 up, or something like that, right? Depending on how it is drawn out. So that's a translation. We won't look as much at that. We'll spend more time looking at reflections and rotations. Okay, so back to our main concept of symmetry. The two basic kinds of symmetry for two-dimensional shapes or designs are line symmetry and rotational symmetry. Okay, so line symmetry is maybe the one that we're most familiar with. Line symmetry is simply a type of symmetry where an image or object can be divided into two identical reflected halves by a line of symmetry. So maybe the classic example of this would be our butterfly. So if we drew a butterfly is supposed to be perfectly reflected, and I guess my picture is not perfectly reflected, over a line. Okay, it can be split into two things, and so you'd see maybe designs, and I'm not an artist, but something like that. You'd see designs, and they're perfectly reflected on either side of the line. Okay, that's line symmetry. It would be a line where you could fold it right in half, and it would perfectly match over. That is line symmetry. Let's look at the other symmetry. Rotational symmetry is maybe a little bit harder to see. It occurs when a shape or design can be turned about its center of rotation so that it fits onto its outline more than once in a complete turn. Okay, so we'll use an example of a square for this. Okay, if we think of where the center of the circle is, this dot right there, that would be what is referred to as our center of rotation. And if we rotate it around there, say we're going to rotate in a clockwise direction, okay, as you rotate it around, you would find that, let's mark this corner right here, as you rotated it around, and say you stopped it at that point, you would not be able to tell the difference that we've rotated it. If you continued rotating it at another quarter turn, and that point got to there, again, it would look like this square and the exact same thing. And finally, one more time, it would rotate. See, so you would be able to rotate it, and at 4 different points around the circle, you would find that it would perfectly match up. It would have that symmetry. Okay? That is called rotational symmetry. And we'll look in more detail about rotational symmetry at a later point. Okay? So we're going to do a little bit of an exercise here. You're going to consider which we'll draw a few images, and you'll want to copy them down into your onto your sheet here, and you will want to be able to label them as whether they have line symmetry, rotational symmetry, or both. And I will check that you got these correct in class tomorrow. Okay. Alright, so these are 4 shapes that I would like you to determine, or 4 drawings, that images that I'd like you to determine if they have line symmetry, rotational symmetry, or both. So A would be a triangle, and you have to pardon my drawing, it might not be exact, but a nice equilateral triangle where all of the sides are equal length and the angles are equal size. B is a capital letter E, where both the top line and the bottom line would be equal length. Okay, and then letter C is 3 equal length arrows going around in a circle, and D is the number 1961. Okay, so work on those, and I will check those in class tomorrow. And hopefully that serves as an introduction to symmetry, and we'll talk more about this in class tomorrow. Okay, thanks.